let's get this again.
This is gonna be better yet.
We're having good morning. Our speakers again through with the COVID stuff, all remote. Reminder, this is only we're having paid members only. Our speakers again, IETA, all those things all remote. Currently we have 48 reminders. This is only we're having paid members only. Our speakers again, IETA, all those things all remote. And at the end of this presentation, we have 48 reminders. This email and we're having paid members only. Send our speakers again. IETA, all those things all remote. And at the end of this presentation, we have 48 reminders. Opened up this email again. We're having paid members only. Send our speakers again. IETA, all those things all remote. And at the end of this presentation, 48 reminders. Support this email again. We're having paid members only. Send our speakers again. IETA, all those things all remote. We're having at the end of this presentation, 48 reminders. Support this email again. We're having paid members only. Send our speakers again. Currently in our budget, we have $1,504.41. There again will be collected dues in 1st of January, and we'll just start collecting again. Today we're having a presentation from Zach from Honeywell Safety Products, and then we're going to be talking a lot about confined space. Also, Brandy is looking for volunteers for IAWPCO. Be on the regional committee. If you're interested, contact Brandy. If you don't have Brandy's information, you can call me and I'll get it to you, or Jason, Dave, or Brian. We can get you her information. So I'm going to turn it over to Zach.
Thank you.
Thank you.
Alrighty. So how's everybody doing today? Like you mentioned, I'm Zach Braden. I work for Honeywell Safety Products. I am a PPE specialist. So, Honeywell, a lot of people know Honeywell from the thermostats. It's essentially the same parent company. So we do a full line of industrial safety equipment, essentially from head to toe. So today what we're going to talk about for the first hour, approximately, we're going to talk about essentially general fall protection regulations, essentially the A, B, C, D. So we're going to talk about your anchor points, your body wear, your connecting device, and essentially if you had a fall, how do you get down? And that's what the D is, descent. How the heck do I get down? So that's what we're going to talk about for the first hour. The last couple hours, we're going to talk about specific to confined space. We're going to talk about essentially the workers in a confined space, what the regulations are. We're going to go over gas detection. We're going to go over fall protection specific to confined spaces, and we'll also touch on respiratory protection. Now, having said all that, this is just a general informational piece. If you have specific questions, you can type it into the chat box. We have a gentleman here that'll read them back to me if you have a specific question. If I can't answer that question while we're standing here, of course, we'll get you an emailed response to your question, or if you're in the audience, if you have a question, of course, just raise your hand. So that's essentially how it's going to work. So we're going to go over fall protection for the first hour. The last couple hours, we're going to go specific around confined spaces and essentially what the rules and regs are, et cetera, et cetera. At about 10 o'clock-ish, and we'll let you know, we are going to take essentially a bio break, and if you need to fill up your coffee, et cetera, we'll take about a 5-minute break, and then we'll restart. So again, if you have questions, just go ahead and type them into the chat box, and we'll answer them as we go. Of course, there's no stupid questions. I have a lot of equipment here, so sometimes I may leave the screen to go grab something to physically show you a particular product for a particular application. So don't worry if I leave the screen. If you have problems hearing, or if there's a problem with the live feed, I think most people should have probably somebody sitting in the room's contact information. Send them a text or call them if something's wrong. If you can't hear me very well, or if you can't see me, etc., just let somebody know that you know is in the room. Or you can even call my phone number that you can see on the screen. So, having said that, so essentially the agenda today, I assume you guys are going to move the PowerPoint over there for me? Okay. So if you just click it a bunch of times to get right there. So we got 2 PowerPoints going, apologize. So essentially here's our objectives for the first hour. We're going to look at essentially the ABCs. We're going to talk about how do you put on a harness. I'm going to literally show you how to put on a harness and show you what bad looks like, what good looks like. We're going to talk about equipment inspection. We're going to talk about fall clearance. We're going to talk about, touch on a little bit of OSHA and ANSI standards. And then we're also going to talk about cleaning and storage, especially now in the COVID world. If you're using shared equipment, we have specific instructions around COVID and what you can and cannot use on your fall protection equipment. And then we're also going to talk about suspension and orthopedic shock. So, you fall, those straps are digging in your leg. What do we do then? So that's essentially what we're going to talk about today. So, I'm assuming most in the room are going to fall under the 1910 standard. Essentially, it's a general industry standard that essentially says if you're up working over 4 feet and you don't have some sort of engineering control, say a piece of guardrail to stop you from falling, you got to have fall protection. So, get the question a lot. What do we do about ladders? You got a step ladder, say a 15-foot step ladder. In this room, we could have a 15-foot step ladder up doing the lights. All right? Ladders, you got to keep 3 points of contact on that ladder to stay in compliance. The problem is, a lot of times, if you're changing a ballast, if you got to hang a sign, maybe you got to go up to turn a valve. Can you do that with one hand? Chances are probably not. You got to use 2 hands. So now the problem is, now you're on a ladder, 2 hands up, only 2 feet on, so now you're not in compliance. The thing is, ladder manufacturers have created those platform ladders where they got the flat platform and they have a gate that can swing behind you. So there are engineering controls, that is your engineering control in that particular application where you can use a step ladder and not have to have fall protection. So, of course, you guys probably have a lot of contractors that potentially come to your facilities to do X, Y, and Z. Maybe it's somebody for a water tower, maybe it's somebody going into a confined space, et cetera, et cetera. Maybe it's somebody just putting a new roof on. Well, there is another standard, which is 1926, that is the construction standard. OSHA requires them at 6 feet. They have to be tied off. Now, as a facility, you can require them at 4 feet to tie off, but their standard, if you don't specifically let them know, is 6 feet. So, because the construction standard is subpart N. You can even see scaffolding is a 10-foot rule. There's even some other rules with iron workers and different things like that. There's even other rules with people that work at substations. I don't know if anybody's got a substation on their property or some substation around. You may see workers at substations with no fall protection on or way above 6 feet. It's because, think about it for them, if they fall, they got power electrical equipment there that can obviously create some issues when they're swinging. So that's the difference between the different OSHA regulations. OSHA makes it very, very clear that is in the employer's responsibility to develop and maintain those fall protection programs. So at each one of your sites around, I think you guys are all around kind of the central northern Illinois area, each site needs to have a competent person for fall protection. And that person is legally responsible for that program and making sure everybody follows the rules for OSHA. All right? And if you're wondering, how do you become a competent person? Honeywell offers competent person training. It's a 2-day class. You also may see differences between OSHA and ANSI standards. Of course, OSHA is what you guys have to follow. ANSI is us as a manufacturer. All of this equipment is ANSI certified. ANSI is a American National Standards Institute. They essentially, if you're going to make a fall protection product, it's got to meet that standard. And they're constantly updating those standards, and that's why we constantly come out with new products, because they change those standards. So you can follow ANSI. ANSI typically exceeds OSHA. They don't go below OSHA. They always exceed it. You can follow it as an organization. Say, yeah, we follow ANSI, because on our written instructions on something like this, on your lanyard here, it may have ANSI regulations and OSHA regulations, and they may be different. Of course, you have to follow OSHA, but you can follow ANSI as well. So just making that very, very clear, but ANSI is voluntary. So you don't really need to know much on this slide. I mean, this is more of the technical pieces of fall protection, but it's good information to know. So essentially, when stopping, let me back up a little bit. A personal fall arrest system is essentially your body wear, your connecting device, and your anchor point. That is what we call a personal fall arrest system. So that personal fall arrest system, when stopping a person in a fall, must limit the maximum fall arresting force on your body to lower than 1,800 pounds. The reason we say 1,800 pounds is because when you think about in a fall, big guy like me, I weigh over 250 pounds. If I fall 6 feet, it's a lot. I'm generating a lot of force. So this system, any system you buy, that's the maximum. It has to keep it below 1,800 pounds. Because at 3,000 pounds, you can potentially get internal organs ripping apart. At 3,600, they can come out of your body. So that's why it's very, very important that if used properly, this equipment will keep the forces on your body below 1,800 pounds. Now, having said that, 900 pounds of force on your body is going to hurt really bad. And it's not going to feel good, but it's better than hitting the concrete or whatever lower level. The other thing is, the second point there, limit the free fall distance to less than 6 feet. Again, free fall is bad in falls. Free fall means that I'm falling and I'm generating a ton of force. So essentially your equipment needs to be rigged in a way that you limit that free fall force. So we don't, like for instance, foot level tie off. When we tie off at our feet, because we don't have any overhead anchor points, it's increasing our free fall. We definitely wouldn't want to go way below our feet, because that's, again, increasing that free fall. So we want to keep our free fall below 6 feet, because that's where your forces jump up, can potentially get over 1,800 pounds using the equipment improperly. It must bring the employee to a complete stop while limiting the maximum deceleration feet to 3.5 feet. Again, these are more technical things. You don't really need to know that portion. And then have sufficient strength to withstand twice the potential energy. So you gotta, that personal fall arrest system has to be able to do at least 3,600 pounds of force. So that's essentially what your product, and that's what ANSI tests to, and what this equipment is designed to do, as long as it's used properly. So, of course, fall protection, probably for the last 20 years, has been the #1 OSHA citation. And OSHA is not typically going out and actively writing citations. The issues are you have a serious injury or a fatality. That's why they're showing up knocking on your door. They're not coming to, I live in Bloomington now, but I live in a little town called Neoga. It's down by Effingham, Mattoon. It's a tiny town. They probably have 6 guys in their wastewater treatment facility plant. OSHA's not showing up there. But I'll tell you, if they had a serious injury or fatality, OSHA would be there probably every 6 months wondering what they're doing, because that's the problem that you got on the list. So of course, what we're trying to do is prevent you from getting on that list. And of course, we want, obviously, to have everybody go home at the end of the day, because nobody's job is worth, unfortunately, dying at the job. So of course, we've got fall protection, which is a 1926, which is a construction standard. And then we also have fall protection training requirements. It's great that you guys are making this available to your members. It's a 3-hour. But again, we need to do this quite regularly, have trainings to bring awareness to fall protection. It can't just be one time a year where the Honeywell guy comes in and he talks for 45 minutes and he brings donuts and we have a merry good time. This is something it's a culture of safety that you got to build if you want people to do the right things. So, here's the main thing. 14 people die every day at work, unfortunately. The #1 thing, anybody know what the #1 reason people die at work? Everybody did it today to get here. Driving. Driving's the #1 way. The second way is a fall. So 2 people die every day in a fall, unfortunately. Most of them are in construction. Most of them are in residential construction. But I will tell you, in the last 2 years, I approximately had about 20 different calls where I've been to where someone has had a serious injury or a fatality, where I'm now coming back to talk fall protection, look at applications, see what they did, provide training, provide solutions, etc. It happens. I can give you very specific examples of people that have been in business, a contractor from here about 45 minutes away. Been open for 46 years. never had a fall. They've had their first fall. And of course, they got their insurance company on them, they got OSHA on them. Of course, they feel bad because it was a small company. They like the guy. He just fell about 18 feet and got seriously injured. They don't know if he's ever going to walk again, just from a fall. So, as you can see, deaths are increasing. Obviously, economy was doing well in these years, so more people working, which creates, of course, more opportunities. So just trying to bring awareness that these things do happen. All I would recommend, OSHA puts out a newsletter that they put out every 2 weeks on the 1st and the 15th. Would highly recommend reading it, and then you'll get the every day. And they bring more awareness pieces in it, but they tell you all the violators, and essentially they give you examples of what happened and how to fix it. So they give you solutions. It's not just telling you the grim reality. So why do these things continue to keep happening? Here's your most common reasons for misuses of fall protection. Not properly calculating the fall clearance. Tell you it's the biggest thing. I go into, doesn't matter if you're a Fortune 500 company or you're a Neoga, Illinois wastewater treatment plant. Nobody calculates fall clearance very well. There's very few companies that do it. So if you're like, I'm not very good at that, hey, join the club. There's a lot of people that don't understand fall clearance and how it works, and we'll talk about it some more. Misuse of rebar or snap hooks. So this is a snap hook here on this retractable. We've got bigger rebar hooks. That's a rebar hook. So misusing these, putting loads on these products, that is not the way it's intended to be used. So misusing those. Insufficient anchor strength, and we'll talk about that, but I can't tell you how many times I've been into places where people are tying off the pipes, and you guys probably have lots of pipes in your applications. There are very, very few pipes that I would never recommend. You would need a physical engineer to tell you whether or not you could tie off to that pipe. Because most pipes are not, that I've seen people tie off to, do not have the sufficient anchor strength. Conduit is another terrible idea to tie off to. Angle iron, another terrible idea to tie off to. Small, you probably have some older buildings here that have those really small steel girders that run across the building. This building probably has them that run up there. Those are terrible ideas to tie off to. So we got to think about our anchor points and having that sufficient strength, because in the event of a fall, a big guy like me, 250 pounds, is going to generate a lot of force. Anchoring below your D-ring. So this is your back dorsal D-ring. Okay, this is going to fit on the small of your back right here. Anchoring below that, because when we anchor below that, what are we doing? Increasing our free fall. So when we anchor below stuff, we got to consider that, and a lot of people don't put that into their fall clearance and different things, and we'll talk about more about some of these things. Attaching two hooks to one anchor point. So I've got an anchor point here. This goes on to a steel beam. If you had an I-beam or something, okay? One person for this anchor point. You can't put two people on this. So if you've got a boiler or a tank and in your shop, hey, I got to get on top of it to change the compressor oil or something like that, one person, you need to have two of these up on that beam, as long as that beam can hold 5,000 pounds per person, which we'll talk about here in a little bit more. Using damaged equipment. Seems pretty obvious, but I do fall protection inspections on quite a regular basis and pull out things for weld burns, rust, rips, tears, corrosion, all things that throw out either the anchor point, the body wear, or the connecting device. Improper fit of equipment. So I'm going to show you. I'm going to show you how to put on a harness, and I'm going to show you some pictures of what bad looks like and what good looks like. And then working outside of your radius, and I'm going to show you an example of what that means. Essentially, if I have an anchor point directly above me, there's only so far I can go each direction, and I'm going to show you a specific example to have it make more sense. And now, some of these things like your radius and your fall clearance, we have an app. It's called the Miller Fall Clearance app. You can go on the App Store or Android. You can download the app, and you literally put in how you're working. Am I kneeling down? Am I laying down? Am I standing up? you put where your anchor point is, and it'll show you your radius and your fall clearance. So you put in what type of equipment you're using, and it'll give you your fall clearance. So any questions so far? No questions? All right. So when we talk about fall protection, OSHA always wants us to go from right to left up here. So we want to first look at engineering controls. If I got to get up on this roof to change air filters, if it's, unfortunately, a lot of the buildings these days, they put the freaking air handlers right by the edge of the roof. So of course, there's a potential application where you could potentially fall off that roof, especially if it's a flat roof or any sloped roof. So what do? The first thing OSHA wants you to do, they want you to engineer out the hazard. If you engineer out the hazard, that's putting up guardrail. Now you don't need fall protection. Now you can walk up there, you don't have to worry about employees, you can put up guardrail, and you can put up any lines and different things like that to keep employees. They know exactly where they can go. If you can't do that, and you can see the gentleman up on the roof there, we use a restraint system. It's essentially a body belt with a chain. If anybody's got any warehouses that have a mezzanine with a second deck where you would be able to put pallets up on it, think about that when you open up those gates. That mezzanine, base of that mezzanine is at least 12 feet, probably more. So when you open up those gates and you've got somebody up there leaning over to talk to the guy down, the forklift driver, I'm giving you a specific application where a guy died in Champaign, Illinois. In that specific application. Because he didn't have any fall protection on, there was no gate, he opened up the gate, he was trying to talk to the forklift driver as he was picking up the pallet, and he fell right down. So, again, that's where a restraint system could be used. Put an anchor point with a chain with a body belt, now you can only go, like this gentleman, right at the edge of the roof. So now you can't even fall over if you wanted to. And then the last, it's essentially what I call the Band-Aid, the PPE. That's the last price. So every time you have a fall protection application, that's what you need to think about. How do we engineer out the hazard? I'll give you a specific example with an HVAC contractor at a plant. They're like, hey, they brought me in, hey, we need to climb up here, go over that, ducting, turn a right, and go all the way up there to go change a motor or something like that. And there's literally, we're standing on a catwalk. I said, why don't you can you move that motor right here instead of having it all the way down there? And they're like, you know what? We honestly hadn't even thought about that. Now, yeah, are they still going to have fall protection as they go and do it? Yeah, but this is something they did like every 6 months to go, I don't know what they were doing with this motor, but they were doing something with this motor. I don't know if it was acting up or what, but that's what they had to do. And I'm thinking, just move the motor over here. Stop going all the way over there so you're removing that hazard. So if you can't do it, now you go to your Band-Aid, the PPE, and use personal protective equipment, which is your personal fall arrest system. So, first question of the day. This is a shock absorbing lanyard. Can anybody in the room tell me how many feet for fall clearance you have to have for this device to not hit the ground? Anybody want to guess for me? It's a 6-foot shock absorbing lanyard, and I'll give you the answer. The answer is not 6 feet. So he's got 20 feet. Anybody else want to guess? It's 18.5 feet. So you gotta have 8. If you currently have these devices, and I'm telling you, I bet you $100 I could find one at every single place you have here. You know why? Because it's the most inexpensive device to buy for fall protection. Because everybody buys it because they see it in a catalog, and this is what they buy because it's inexpensive. 18.5 feet of fall clearance, and I'm going to show you exactly. So we have this device, so we show the device on the right, this device. So this is the upgrade. So they made these, before my time, but I think 1999 or 2005, I can't remember, is when this device came out. Essentially, we still make these. We still have people, there's still applications where you can use a lanyard. Then we came out with this device. This is what we call a personal fall limiter. So how it works, different from your lanyard, it just comes out like a seatbelt, and then when it feels free fall, it stops. It's magic. You know, there's brakes in there, and it feels the free fall, feel the free fall, and it stops like a seatbelt. So you can see, if I have my anchor point as high as possible and directly above me, and I fall, that's my fall clearance. So I'm going to show you this graph here. This is going to be the first one. So if you're wondering how I got to this, this is in our user instruction manual. I know a lot of people don't read user instruction manuals, but essentially this training doesn't replace the user instruction manual because there's information like this in it. This chart comes exactly from the user instruction manual, and you can see there, before a fall, you see the guy standing, and you see after a fall. That is with this device right here. That is how you're getting, so you got the 6 foot of the lanyard, you've got up to 3.5 feet of deceleration. And I'm going to show you a used one of these and what it looks like. So this is going to stretch because that's how it's slowing you down. That's what's absorbing the fall, is this device stretching. You've got 1 foot of harness stretch. So your harness, your back D-ring on your harness in event of a fall is probably going to be right here above your head because it stretches. So you got to put a foot of harness stretch. Then you have the 5 feet tall, so from your back D-ring to your feet, that's another 5 feet of clearance because, of course, you don't want to fall and nail your legs on the ground because now you got broken legs. And then you put a 3 foot safety factor in. So that's how you get to 18.5 feet. So not saying that every time with this device is going to be 18.5 feet because it depends on how you had your system rigged. Are you tying off of your foot or is the anchor point above you? That's going to greatly depend how much free fall you have, which is going to depend on how much forces go on this, which then how much forces translates to your body. Again, it can't go more than 1,800 pounds because that's how it's tested and designed if it's used properly. But you may not hit the full 3.5 feet of elongation, but you may, depending on how you have it rigged. So I'm going to show you this version, which is your self-retracting line, or your personal fall limiter, like this device. Now, you see on here, it's a maximum free fall distance. The maximum. So what we call this device, so there's 2 types of self-retracting lifelines. There's a Class A retractable and a Class B retractable. And then there's also what they call a Class AB retractable. So a Class A retractable must stop within 24 inches. So in the event of a fall, the maximum, it can't go more, it's 24 inches. So if in the event of a fall, potentially, the maximum this could go is 24 inches because that's how it was tested design. We have a big fall protection training lab. It gets certified by ANSI that this has to stop within 24 inches. Now, as you see, I've pulled it 3 or 4 times here. It stopped within inches. But the maximum is 24. That's what the standard says. But in reality, probably going to stop within inches. Now, I can't say that definitively. Obviously, there's going to be devices that may take a little bit longer because there's a break in here. Depending on where you're at in the break, it may be a couple more inches, etc., etc. So there's 2 feet there of your maximum free fall distance, and then there's up to 2.5 feet of deceleration distance, which is what this is. The device here may not deploy. This is your shock absorber. So this is, again, if you hit over that pound limit, that will deploy. Not every time in a fall it will deploy. Only deploys when it knows that there's forces on your body that are getting up above 900 pounds. And then you've got the 1 foot of harness stretch, you've got the 5 foot to the worker's back, and that 3 feet of safety factor. So you've got the Class A retractable, must stop within 24 inches, but keep the forces on your body to below 1,300 pounds. That's what a Class A retractable is. A Class B retractable, which is typically in your bigger units, 20, 30, 50 footers, those are typically Class B. Those have to stop within 54 inches maximum. 54 inches, they have to stop within then. But then it keeps the forces on your body to below 900 pounds. What's nice about this device, and we were, finally somebody copied us and figured it out, is this is a Class AB retractable, meaning it stops within 24 inches and keeps the forces on your body to below 900 pounds. So you get the best of both worlds. So that's what this device is and why it took off in the marketplace, because it's what they call a Class AB retractable. Now, there's other manufacturers that now make the Class AB, but for a long time, we were the only one that had it. So this device, much safer, and we'll talk more about why I would suggest if you currently have these devices, to go into this. Because how many times are you working that you're above 18.5 feet? And we'll talk about specific examples later about why this is not good and why we should use these. So when we talk about swing fault, this is what I'm talking about when we work outside of a radius. So you can see the example, and I'll give you a specific. So essentially, it creates the pendulum effect. So if my anchor point, if you're looking at me, and my anchor point is way over there on the other side of the room, and I fall, I'm going to fall back to my anchor point because that's where it's pivoted. So if I give you a picture, if you can go to this picture, you can see the gentleman up. This is one of our fall protection guys. We were going to a construction site to do a training. And this is the picture we see. So you see the guy, the equipment he's using is fine. He's just not using it correctly. So you've got the gentleman over there. He's using our lifeline. He's on a rope grab is what he's on. But instead of having that anchor point over about 30 feet probably, he just walks over to the left. Does anybody see the problem with that? When he falls off that roof, he's going to hit the ground probably by that fence. It's not going to do anything. So what he probably should have had is either like some sort of lifeline system running across the top of that building so he could walk back and forth, and then that reduces your fault clearance as well. Now, it's not as simple as that for that particular application because he's not very high and you're using a lifeline system. There's some more that goes to it, but that's essentially a solution that you could have done or had somebody up top. Again, what he did was a bad idea. It's a bad situation. So if he falls off that roof, he's hitting the ground every time because the equipment's not going to do anything. So, A, B, C, and D. So first what we're going to talk about is your anchor points. And what I'm talking about here, there's a difference between an anchor point and an anchorage connector. An anchor point would be potentially that beam that runs across. An anchorage connector would be a device like this. This is your anchorage connector. I want to be very clear on that because what this is talking about on this slide of anchor points, you've got your I-beams, large rebar, concrete column, wood joist or beam, supported steel structure. We want that anchor point to be as high as possible and directly above us. Now obviously, I'm a realist. That can't happen in every situation. But the point is, it must be capable of supporting 5,000 pounds per worker. So if you guys have work trucks, if you can't hold a work truck off of that, your Dodge, Ford, GM, Chevy, whatever brand you want, if you can't hold that F-150 off that anchor point, you can't tie off to it. It's got to be able to hold 5,000 pounds of static load. Now there is ways to test that. Of course, there are physical engineers in the world that can certify anchor points. You can do that. But as a layperson, us in here, and I'm including myself as a layperson because I'm not an engineer, 5,000 pounds per worker. Now, an engineer may be able to rate down to 3,600 pounds. An engineer might be able to, not you guys. 5,000 pounds. So if you can't hold a truck off of it, you can't tie off to it. Now, this is not 5,000 pounds because this is your anchorage connector. Your device like this will have a label on it that'll tell you the exact poundage of your anchorage connector. Because some anchorage connectors are going to say 400 pounds, some might say 320 pounds. That's of your anchorage connector, not your anchor point. Your anchor point is 5,000 pounds. Your anchorage connector is on the label on the device. All right. So we got a bunch of different types and styles of anchor points or anchorage connectors. You've got potentially carabiners. You've got a grip anchor. I don't know what I did with my grip anchor, but it's around here somewhere. Like this. This is a concrete grip anchor. It's movable. So essentially, of course, to the specs of how do you install it, you can put it in, load it, now you got an anchor point hanging out there where you can connect your fall protection device to. They even make fixed anchor points like this, like go on an I-beam. You can put it overhead on an I-beam, it just sits there, as long as, of course, you install it to the user instruction. I already showed, we got swivel versions like this, and obviously there would be a bolt here, but this swivels. So you can put it on a roof, you could put it on a overhead ceiling, concrete, we make them for everything. So you got a swivel anchor. The most common anchor point is your cross arm straps like this. So this is a cross arm strap. So essentially, if you had an I-beam, rebar, etc., you could throw it over the top, you loop it down, and now you got your anchor point hanging down. These are all temporary anchor points. Now, the thing is, they come in 2, 3, 6. We'll make a 100-foot cross arm strap if you want. A lot of our fall protection gets made in Franklin, Pennsylvania. They'll make them as long as you want. The longer, the better, because you can always make it shorter. So if I've got an I-beam and I want to get it, increase my fall clearance, because we want it really tight to that I-beam, you just wrap it twice around that I-beam. Wrap this twice around that I-beam, and then pull it back through, whatever length you need. We also make these in Kevlar, so if you're a welder, or if you're constantly throwing around beams and stuff like that have sharp edges, this is nylon, it's going to rip. We make a Kevlar version of that, but this is one of your more common versions. We also have cable. This cable, again, can go on a I-beam, etc. It's got a little D-ring here that hangs down. That's where you would attach your connecting device to. This, open up like that. Now you gotta, and it's hang down. So that makes sense to everybody. It opens up like that. You can put it up, swing it over. Now you got your anchor point hanging down. I know this doesn't look like much, but 310 pounds is what this anchorage connector is rated for. So a bunch of different types and styles. Of course, if you have specific questions, I can most definitely come to your plant and we can look at a specific application. Most of them, they even have, I didn't bring it, but they have the beam trolleys that run along a beam. So if you have, again, a boiler or something like that, or some sort of chemical storage where you got to get up and you're constantly having to walk back and forth, now that moves with you. Same thing with this. This is what we call a shadow beam anchor. This will move along that beam, of course, as long as there's not obstruction. It'll move right along that beam with you. So your anchor point's directly above you at all times. So little things like that can potentially help. We even have that one that says temporary anchors on the bottom, second from the right on the bottom. That's a first man up device. It's essentially got a pole with a hook that you can attach a retractable to, where you could be standing right here on the ground, push it up, put it over that beam, and then now you got a tag line to pull down the anchor, connect to you, and now you can climb up and put your temporary or permanent anchor point up there. It's called the first man up device, is what that is. So of course we make roof anchors. I even brought this. Jason said you might have some standing seam roofs if you got to get up on a roof. This is a standing seam roof anchor point. It's got clamps here that are adjustable that you can attach to the standing seam, and now you have a anchor point here. This has got a shock absorber in it, so it'll protect the roof and you. Essentially, now here's your anchor point. We can also run permanent anchor points exactly like this on rubber membrane or concrete or wood, and you can even run lifelines, which I'll show you here in a second, with one of these devices. Like that, on the top left, you see lifelines running. So if you got to get up on top of a building, etc., you can have lifelines run. Or if you've got the big circular water that don't have, your big water tanks that don't have guardrail around them, you're like, hey, how are we going to go work on the side of that? Maybe you got to do whatever. Well, you can potentially use a lifeline system depending on your setup. Of course, every setup is going to be a little different. You can see up at the top right, and I brought one, got one here, is essentially a temporary lifeline system where it comes with 2 cross arm straps and rope, and you essentially put those 2 ropes essentially like this. It's got rope like this. You'd attach one to a cross arm, you got the other cross arm, and then it's got 2 rings on it. Now you can have up to 2 people with a temporary lifeline system, running between 2 posts and different things like that. You can see the bottom as well. That's the version of that. So that comes in a bucket. That's something that can be transported depending on the application. All right, so now we're going to talk about harnesses. No questions so far? Okay. So now we're going to talk about harnesses. We make a bunch of different types and styles. You can spend $50 bucks, $30 on a harness. You can spend $600 on a harness. Depends on what the application is. You know, a $30 harness, not going to have a lot of features. Maybe you use it once a year. That's what a $30 harness is for. If you're going to be climbing up water towers, if you're going to be welding, if you're an electrician, you're going to get closer to that $600 because your harness needs to be comfortable, but then it needs to have arc flash properties, welding properties, et cetera, which of course increase that price. So it's very, very key to identify the right harness for the right application. So electricians probably need to be wearing an arc flash rated because they wear all the arc flash rated clothes. If you don't have an arc rated harness, it doesn't make much sense. You know, so your outermost piece of clothing needs to be arc rated. So, question. How often is you, as the wearer, how often do you need to be inspecting your equipment? Every time you put it on. And that goes for your harness, your anchor point, and your connecting device. Do a quick visual inspection. Every time you put on your device, you need to inspect that equipment. So that's why it's kind of important sometimes if you have workers that wear harnesses all day long. You want them to get a comfortable harness so they never take the dang thing off. We have a really comfortable harness here that you can wear. It's got padding in the legs and the back. You wear it all day long. It's stretchy. It's really easy to adjust. Now, if you buy the $30 harness, yeah, it's got friction buckles. It's tight. The person takes it on and off all day. So then they got, by OSHA regulations, they got to inspect that piece of equipment every time they put it on. So what am I looking for when we look at a harness? So you've got a harness like here. You just grab it like he's got it by the back dorsal D-ring like that, and you're going to inspect the webbing. You know, the webbing's the main thing. This is just nylon. It doesn't last forever. So essentially what you're doing is you're feeling for imperfections in the webbing. And you can feel it right away when you inspect the equipment. You can feel when something has been potentially worn. Now, if you've got a harness, anybody in here have a harness more than 5 years old? And it's your harness? Yeah. You know, it might look brand spanking new on the outside. I don't know how often you look at it or how often you wear it. He's a supervisor back here, so I assume he sits in a truck all day and on his computer and his phone. So, but anyways, if you look at his harness, it may look brand spanking new, but if you look where the metal and the nylon meet, I bet if I pulled that out like this and felt, I bet I can feel exactly where, if it's over 5 years old, I can feel where that rubber, or that metal has been hitting that nylon. That's where all the weak points are because it's his harness. He probably doesn't have anybody else, so it never gets adjusted. So every time he wears it, that's where it's constantly rubbing. So that's where you potentially gotta feel and adjust. That's why it's important to have harness. You see how, when I put this on, you'll see how easy this is to adjust. That's why it's really important to have that, because if you have a harness that's inexpensive, it's hard to change those friction buckles. And let's be honest, people aren't moving the friction buckles because you don't want to sit there and yank on them. Well, they just leave it. And especially for your workers, they're wearing coveralls in the winter. So now their harness is just a little bit tighter. So now it's rubbing a little more. So that's where you're going to check, is essentially places where metal meets nylon. You're also going to check, of course, if you've got the quick connects, which is what this harness has, quick connects even on the legs. And what you're going to inspect, this is a two-step process to open. So I can't open it if I only hit one. I hit the other one, doesn't open. It's got to hit both of them to be able to open. If this stayed open, it's a reason to take this out of service. So of course, weld burns. Can't tell you how many times I've looked at harnesses with weld burns. I got one particular customer that's got about 30 sites in Chicago. They weld all day long doing different things to mine. There are weld burns on every harness when I go in there. I could, each site, I could probably pick out 5 or 6. Because a lot of times I'll buy this harness, which is a nice harness, don't get me wrong. It's not designed for welding. So we have finally got most of them to a harness that's got welding, because all that slag and stuff, all the burn holes are always right here where the fabric folds over, because that's where the weld bead sits, and it burns a hole right through the rubber, or right through the knife. So rust, cracks, tears, etc. That's all reasons to take fall protection out. We do have, and we can make this presentation available. Again, these things on these pictures come right out of the user instruction manual about how to inspect the different pieces of equipment. So same thing with on your lanyards. You know, I hate these devices because when people are like, oh, I got these, you got to inspect 50 of these are hard to inspect because you got all this fabric that's got to be pulled out like this. Because again, tears, you know, this is long. You might tear it as you might get caught on something. You might have somebody weld, and that's where all the burns are going to happen. You literally got to pull all this out and inspect it. And you're feeling and looking to see if there's any imperfections. The other thing is you're going to check your gates. All right, so ANSI updated the gate standard. There should be a stamp. I don't know how close I am. You can tell me how close. Right here on the end of the carabiner, there's a stamp on there that says that the gate is 3,600 pounds. They're talking about this portion. There might be a stamp on your equipment that says 5,000 pounds. That is talking about this. The gate also, depending on the device, if you have a tie-back unit, like this, that has a hook like this, it might say the gate is 5,000, might say the gate and this portion is 5,000 pounds, but this is a tie-back unit, so it's a little different. So this gate is actually 5,000 pounds. So just making it clear, there could be two different stamps as long as it's a tie-back unit. And what I mean by tie-back means that this unit is designed to tie back on itself like that. Not every device is designed this way. You have to have a specific unit that's designed this way. All of ours will have a hook that looks like this, it's square. This gate on a tieback has to be 5,000 pounds. Now, on every other device like this, the standard is 3,600 pounds. So if you have old equipment, and I'm saying old equipment in the last 5 years, chances are you don't have that ANSI stamp on there that says 3,600 pounds. The previous standard was 360 pounds. So you can see they increased it by 10 times. The problem was this part was always been 5,000, but say it moved and it put the anchor point on the gate and then having gates blow out. So that's why they updated the standard. So you need to have a stamp on your carabiner that says 3,600 pounds. That's an ANSI regulation. And everything that you buy from us from now on will be 3,600 pounds. So if you buy new stuff, you're good. It's what you need to inspect your old stuff for that 3,600 pounds. So you got to check both sides of your carabiners. You're looking for rust, tears, cracks, etc. On your retractables like this, you know, of course, you know, there's different types of carabiners. This is a twist lock version. You know, this is a two-step process here. You got to hit the bottom and then hit that to open. If it were to stay open and not close, it's a reason to take this out of service. The other thing, you know, of course, you got to check your webbing. Pull it all the way out. And what I do is just feel it. You're feeling it as you go in, okay? No imperfections. And then what I do, make sure it actually works. And if you get a brand new product, buy it from Honeywell, 100%. Make sure it locks up. Make sure everything's here. You know, we're not perfect. We have manufacturing errors just like everybody else. So make sure it works. If it doesn't work, you got problems. It doesn't, you know, it needs to be taken out of service. Having said that, if you have to take a piece of product out of service, you got to cut it up. Immediately needs to be destroyed. So anything that you deem or who your competent person deems, and you can even have somebody like me, if you're like, hey, we don't have a competent person because we're the town in Neoga that has only 6 guys there, I'll be more than happy to come and show you how to inspect equipment. And I'll even inspect your equipment. But the thing is, if somebody like myself, the competent person that's a third party, comes in and inspects your equipment, if I say it's bad, it's bad. You know, there's no arguing with that competent person. And that goes for if you are the site's competent person, and I don't know if organizations like this have the CEO or the chairman or the president, and he's like, oh no, we're not buying any new fall protection equipment. Well, legally speaking, you're the competent person. You can tell him, yeah, we do, because it's a life safety issue. And you're deemed legally responsible. Now, I would recommend getting your employer to tell you that, hey, you are, from a legal standpoint, that you are that competent person. You do have the right to inspect equipment, and you are our competent person. Just get it in writing. Just cover yourself. But you are the competent person. If you say something needs to be thrown out, it needs to be thrown out. And any question that anybody in the field has, if you're not a supervisor, if you have a question on whether or not there's a sufficient anchor point, whether your equipment's good, that's the person that you need to go to and ask, hey, do I need I think this is a tear. Is this, I'm unsure, is this actually a tear? Take it out of service? Take it to that competent person, and they're the ones that can tell you. But essentially, when in doubt, throw it out. You know, we've got the pictures here of what to look for, etc. You know, we do have YouTube videos where you can watch the inspection process. I have documents that I can provide that literally, I mean, one of them is 48 pages that literally goes through all the different devices we have and what to inspect. But a bunch of different types and styles. Manufacturers, you know, all make something a little different. Mostly everybody does kind of the same thing, so it's, you know, it's, you look at the same for the same things. But there's different fall indicators as well, which we'll show here in a second. But, you know, here's what bad looks like. Again, these are pictures that we've been to customers and taken stuff out of the field, and we just don't, you know, make this stuff up. So you can see on the left there, some of your carabiners, like if you have this confined space equipment that has this hook on it, that's how you know that this device has been in a fall. You see before and then after, you see that red? That tells you that that device has been in a fall. You can see, of course, the weld burns on the bottom left. You can see terrible, you know, barely hanging on, rust holding open. You can see that. That looks brand new, but the carabiner stick's open. So that's a problem. And then, of course, even more rust. So I've got my second question here. Can anybody in the room or on the video tell me which one's good? And I'll try to get a little closer. Anybody tell me right or left hand which one's good, which one's bad? And I'm giving this as an example because a lot of times I see these hanging up in shops. And if both of these are hanging up and you don't inspect it, how do you know which one's good? All right?
The one that's closest to me is the good one.
Yeah, so the one in my right hand, this is the good one. This is the bad one. So you see the difference, and when I pull it out, you see that little red flag? Now, it used to be a lot longer. It got ripped off. But that's the flag that tells you that this device has been in a fall. As you see this device, how it's folded up there on the screen, how it's got the fabric folded up, that's your fall indicator. And the reason I say that is because if you use something twice in a fall, again, this is what happens. I did this device with our dummy, and this is what happens. So you can see the housing's cracked, the pins are falling out. This was after 2 falls. So granted, this device, if you use this improperly and hooked it up, would be a lot worse than this, because this was an overhead application where he fell maybe, you know, a couple inches. If you tied off at foot level, this thing's probably going to break, because this is essentially not a disposable unit, but it's a one-time use unit. Once you fall in it, everything got to be taken out. Harness, retractable, the lanyard. So here's a lanyard, all right? So here's what good looks like. Here's what bad looks like. So you can see this is a 6-foot lanyard, and I'll put the eyes at the same height so it kind of gives you an example. That's what happens in a fall. And you can see how much elongation happened. You can see how this part's super flat. That's what was slowing them down in a fall. That's what we're talking about in a fall protection application. And you can see here, this has got the flag that comes out that tells you, retro, this has been in a fall. Equipment doesn't lie. You got it, you know, the forces on your body in a fall, you can't fake it. It's not just simply you're walking on catwalk and you fall down. Probably not going to put that in a fall. The other thing, anybody tell me what's, you know, this looks probably a lot like some harnesses I could probably find at your shops. Can anybody, am I good on the screen? Anybody tell me, looking at this harness, what's wrong? So, missing tongue buckles. It's a reason to take this out of service, no tongue buckles. This is a harness that we took out from a factory. The other issue, we're looking right back here on the back of the E-ring. Anybody see an issue there? Right in here? Yeah, you see all these strings hanging out? It's because this has been in a fall. This is what good looks like, what it should look like. This is what it looks like. So somebody at this factory that we took this out of had been in a fall and just didn't tell anybody. The problem is, if you've been in another fall, I can't guarantee you that this is going to do anything. It might break because it's already absorbed how many ever thousands of pounds. So that's your fall indicator. So, you know, we've got a brand new harness here. It's got both of them folded up. There is another fall indicator on this particular one. Fall, it didn't break, but there's 2 clips right there. If you have some other harnesses or more inexpensive harnesses, they have these black plates. Those break in the event of a fall, potentially can break. So these may not always go out, but this may, depending on how you fall. That's why there's 2 indicators. So this has been in a fall. So it doesn't really look that bad, from a distance. Yeah, going where? But now when you actually do an inspection and a competent person inspected it, now we found somebody had been in a fall and didn't tell anybody. So now I'm going to show you real quick, because I know we're getting a little bit past 10 minutes. We got about another 10 minutes or so if you got a bio break here. But essentially, how you're going to put this on. I always attach that first. Then you've got your legs here. It's a 3-finger rule. Okay? If I can fit 3 fingers in there, I'm good. If I can fit a full fist, it's too loose. And that's standing up. Of course, I can probably put a fist in. Let me just show you real quick. So I can put 3 fists, but if I lean over, okay, I can put a fist in. I'm not worried about here because I'm not standing like this. Well, I'm standing straight up. If I can fit 3 fingers in, good. If I can fit a full fist in, which I can't, that means it's snug enough. And I want these straps right up in my groin. Ladies, if there's any ladies on the line, same deal. You want these straps right up in your pelvic region. Anybody know why you'd want them up in your pelvic region? Because if I can tell you, I can go to a manufacturing plant where there's a bunch of contractors working right now. Bet you $100 I can find about half the guys with their straps down like that. I can go to a DC, I know a specific DC, where all the people have their straps down like this. So in the event of a fall, I know, realize, everybody in here may say, we have never had a fall. Okay, the one time you do and you have your straps down like this, where do they go? Really fast. And we used to be able to show a picture of what the after was. It ain't pretty. Now, I'm being very, very serious. You want these straps up in your groin, up in your pelvic region, and you want them snug. The other thing is, I get in a habit when I do these. I don't have my car keys in my pocket. I don't have a knife, a screwdriver, pins, because where do these straps go? Right over my pocket. So yeah, if I don't fall, yeah, it's kind of annoying, but no big deal. But if I fall, where does that knife go? So I just told you, you could potentially up to 1,800 pounds of force, and a lot of that force is going to be right here on your legs. And now you just impaled that knife, that screwdriver, car keys, your phone, all that stuff is going to be destroyed in your leg, causing an issue. So make sure you take things out of your pocket, but we want to keep it nice and snug. We want to keep the chest strap right here at our breastplate. Same thing for ladies. Keep it right here at your breastplate. Ladies, if there's any ladies on the phone, we have a specific harness designed for females. It's a little different than this style. It's kind of going it from the side, but we have a specific harness designed for ladies. So if you have any ladies, we can, I'm pretty sure I still have one. So we can do it there. The other thing is your back dorsal D-ring. We want it right here. That same construction site, $100 we can go there and I can probably find about 4 guys with their back dorsal D-ring right here. Has anybody seen the problem with your back dorsal D-ring hanging down that low? When you fall, you're going to fall like this. And that's all that weight is on your gut. And so we want to fall like this because we want all that weight on our back and our hips. We don't want it on our gut because we don't have anything holding our gut in. So we want to fall like this. So we got to make sure that back dorsal D-ring's there. We also want this at our breastplate. We don't want it too high or too low because in the event of a fall, I've already told you, it's going to have about a foot of harness stretch. What happens when it's too high? Hits you right in the face. If it's too low, you may fall out of your harness, and depending on how you fall. All right, so that's why it's very, very, very important. I know it seems pretty basic on how to put on a harness, but again, I can go to a lot of different places and see people that just get into a habit of putting on their harness and everything's loose. In the event of a fall, it is not going to feel good if you fall. So what's nice about this particular harness is it's really easy to adjust. Okay, you just pull those down. like that, and to tighten it, so now it's really loose, so maybe I need to go in the truck and drive. Now I'm ready to work. I can literally just pull it up like that. And that's literally how easy it is to adjust this harness. You don't have friction buckles, so that's how easy it is. So this is why I'm saying how it's nice to buy a nice harness for somebody, because that's how now I can work, and it's a lot looser, and then when I'm ready to work, I just pull it right back up. Okay? This particular harness has the quick connects. I personally do not like quick connects. I would get the version that has the tongue buckles, especially for your guys' application where you're working outside and you're always having to put your outermost layer of clothing on, as Carhartts and different things like that. The problem with this is people don't make the adjustment. Whereas if you have the tongue buckle, you're making the adjustment every time you put it on for your legs. So, there's your pictures on the left of incorrect harness fits. So you can see the guy, way too high, way too low, way too loose, way too low. And then of course you can see our male model. We had bodybuilder there, and then there's actually that female harness. If you're wondering what that female harness is, there's that female harness. It's a little different. Oops. You go into it kind of in the side, so it's a side entry harness, but there's your correct fit for both males and females. All right, so we make a bunch of different types of connecting devices. I'm not going to go through all these. Of course, we can share the presentation. There's a bunch of different types and styles of connecting devices. The main thing I want to say here is there is a new requirement in retractable lifelines. So this particular unit is one of our most popular personal fall limiters. You can get this with a bunch of different style hooks, but this is a turbo light. A lot of people use it. The problem is this particular device is not designed for foot level tie off, and it is not designed for leading edge applications. You're going to ask me, well, what's a leading edge application? A leading edge, we find that 80% of the falls happen over an edge, whether it's a piece of equipment, edge of the building, whatever. Those falls that this lifeline couldn't come in contact with that edge. So the problem is, we're going to use this as an example here. If I'm up here working and I fall off this podium, fall off here, now I've got, this is what I'm talking about, an edge. My anchor point's back here, my body's down here, and now it potentially is rubbing and snapping because it's not designed for an edge application. What we've created, and there's a new standard around it, this is just a double leg version of it, but we have both cable and smooth edge designed for leading edge. So this is designed, when it goes over that edge, it won't break. And it has this shock absorber in conjunction with it. And if you want more information on this, I can send you a YouTube video that shows exactly what I'm talking about. And devices like that, even cabled versions, breaking in those applications versus this not breaking. So this is a new standard. This is going to be the way of the future. For some applications, not every application, you don't need this device. But again, there's both cabled and webbed options, but it's called a leading edge. This device here can be used for foot level tie off. So if I have to tie off at my feet because there's nothing above me, that particular device can be tied off at foot level. Now, having said that, your fall clearances are much, much different with a leading edge retractable than a standard retractable. It's because you're tying off at foot level. So there's literally a chart that comes in the user instruction manual that gives you, hey, if I'm working here and I have this setback, this is what my fall clearance is. So just keep that in mind, that your fall clearances are going to change. It's not just going to be your same 6 foot because you've got that shock absorber in there and you're going over the edge. So we got a bunch of different types and styles of leading edge retractables. You can see the application there with the guy. If he falls over, he's going against that concrete and the anchor point's over there. So if he fell over right there, he's going to swing. So that means that retractable is going to swing on that edge. So you got to have something that's rated for edge. So essentially anytime the SRL is connected at foot level or anytime there's a possibility that the lifeline can come in contact with an edge. So we find that 80% of those falls. So here's one thing where I see a ton of misapplication. I'm assuming you guys have bucket trucks, or maybe have bucket trucks, but I'm sure you have a JLG probably running around somewhere. No? Does anybody have JLGs? So no JLGs back there, but I saw a yes over here. So anybody know what the problem is with a JLG and driving a JLG, moving a JLG around? I bet you if the people are out working today, we can probably find somebody driving one around and using this device. Because you don't drive it at 18.5 feet, you drive it at 6 feet. Anybody hit a bump in a JLG? What happens? Pops. The problem with using this device is you're not 18.5 feet off the ground. So chances are if you pop and hit a bump, now you popped out of the basket. The problem is you're going to go up more than 6 feet and you're going to come right back down 6 feet. And the bucket's probably what? Maybe, I don't know how high it is, 4 to 5 feet off the ground probably, I'm guessing. Maybe depending on the size, could be higher than that. But that's the problem with this. The other problem is, and I thought I was going to see an industrial accident at this place. I'm literally standing right here watching it. There's 3 guys in JLGs and a forklift at this manufacturing plant, buzzing around them. They had no cones out. It was a disaster waiting to happen. Thankfully, nothing happened. But if that forklift hits that JLG and makes it bounce, what happens to the person? They bounce too. So this is why this is a problem in JLGs. Yeah, if that person falls out, okay, he's saved if it doesn't flip over or whatnot. He still doesn't hit the ground. But the problem is, but now I can potentially maybe go up into the ceiling like that high. Would have gone up into the ceiling, hit the steel girders and came back down, and now he's hanging outside the bucket. Whereas the difference is if you have a device like this, and I'm using it, and hit a bump, that's all I do. Or, you know, if I got it out a little farther, that's all the farther I'm going. So yeah, I might still hurt because I may hit the sides because it jolted me, but I don't, if I do fall out of the bucket, that's all my fall clearance is, so chances are I might be able to self-rescue because I can just climb back up on the JLG and climb back into the basket. Whereas with a shock-absorbing lanyard, you're not going to be able to self-rescue because you're going to be at least 9 feet probably below the basket or maybe 6 feet below the basket, and you're not going to be able to help yourself, so you're just going to be hanging there. So that's why in JLGs we recommend, and there's a specific page in our user instruction manual for a JLG in this particular device. All right. So I don't know if anybody getting on roofs. This is more for residential roofing, so I'm not going to touch on it. But of course, roof safety is a major deal within fall protection. So the other thing I want to talk about, fixed ladders. So OSHA came out with a new standard. Any ladder over 24 feet, got to have a ladder climbing system. Those would be new installs. So say your system is putting in a new water tower, you are required, or that manufacturer of that water tower is required to put in a ladder at the time of installation. If you're going to put in a new tank, maybe it's a salt tank, a chlorine tank, or whatever, that's 40 feet in the air, and you've got a fixed ladder on it, doesn't have a staircase, you're required to put a ladder system. Now, OSHA said, and I can send you more information if you're like, oh shit, I got a bunch of fixed ladders, or I got one ladder that's really bad and we hate climbing it. I can send you all the documentation that talks about all the OSHA regs, so just make a note. I've got my email here. You can call me, email me, and we can discuss it further. But if you've got a ladder 24 feet and above, that's new. Now, if you've got a ladder as well that needs to be painted, a rung needs fixed, you got to do any kind of maintenance to it, OSHA is requiring you to put in a ladder system immediately. You can't wait. Now, if you just have a ladder system and it doesn't have to be painted, doesn't have to have any maintenance, and it's existing, you have until 2036 to put a ladder system on that. So you got a long time. So if you're like, oh, I'm close to retirement, whatever. The problem is, if you identify that ladder as a hazard, and it's even below 24 feet, it's usually 12 rungs, 24 feet is what we usually consider. But say you know it's a safety hazard, put in a ladder climbing system. Now, this particular system is a rail system. If anybody's ever done any tower climbing, long ladders, maybe in your water towers have a little bit different rail system. We actually, if anybody has a water tower that has a safety climb system, that's it might say North on it. That's a Honeywell ladder climbing system. It's very big into water towers. So if anybody's got a water tower on your property, it'll have potentially that safety climb system. There is a rail system like this. It's a rigid rail is what they call, or it is a rigid rail, but it's just a rail system where essentially you hook up your carabiner to that and it just glides right up the ladder. You can, if you've got multiple levels, you can literally, they make little closeout places where you can move your carabiner out to step off to go work and then get back on. But the other ladder system, which I have a system, it's just a little bit bigger and I had a bunch of stuff so I couldn't bring it. They have a cable system as well, which is what you see on the screen. That's a cable system. Much more inexpensive, and if you have ladders that are, we say below 300 feet, but below 60 feet, go with the cable system. Even 100 feet, go with a cable system. It's much more inexpensive. It's really easy to install. You guys can install it at your plants yourself. And it's just a lot easier to use. The difference when you get over 60 feet, I say 60 feet, because if I had to climb a 60-foot ladder on a cable system, my freaking arms and legs are gonna be tired. I'm gonna be honest, I don't climb ladders for a living, so I'm gonna be tired. Whereas the difference on a rail system, if you put a rail system in above 60 feet, when you climb the ladder, you can literally climb it with no hands on the ladder. You can just climb with your feet because this is rigid. So you just literally, you have your chest D-ring that's attached. You can just, if your arms get tired, you can just climb up. Or if you need to rest, you just kind of lean back a little bit and you're nice and snug and tight. Whereas the difference between a cable, there's a lot more sway in the cable. So when you lean back, it's a little bit harder to lean back and you can't not climb with your hands. You have to climb with your hands at the cable. But that's the difference that we've got. There's 4 different options for ladder climbing systems. The cable is by far and away our most popular. Then this glide lock system. For water towers, it's a safety climb system. And then we also have a option where if this was the top of the ladder, you can put a davit post up top that has a retractable lifeline where you just pull the lifeline down to your employee. They attach it to their back D-ring, remove the tag line, and they just climb up the ladder. So we got 4 different options for ladders. But there are definite issues and definite dangerous places that I've been. Like this building, I don't know where the roof access is, but if it's got a roof hatch, it's a very dangerous going from ladder to roof. It's very, very dangerous. Trust me, I've been on Allstate Insurance's building right there. If you've been in Chicago, they got a huge campus. I've been on the top of that building. They have like a 30-foot rinky-dink ladder to get on the top of that building. And going from roof to ladder and ladder to roof is extremely dangerous. And we were looking at lights to put on, how they were going to change out their aviation lights. I'm thinking, Jesus, that is more of a hazard than you walking out there putting that aviation light on. So there are definitely some dangerous ladders. Maybe you've got a tank that's got like 3 ladders to get up it, where they might have a 30-foot rung, and then you step off and climb up another 30-foot rung and step off and climb up another 30-foot rung. Well, the problem is, you may have cages, and cages are not fall protection. Cages are essentially, we know where to find you if you fall, because you're going to be right down at the bottom of that ladder. That cage isn't going to do anything. All that cage was originally designed for, when you're climbing up that ladder, is to lean back on it so your arms could rest. That's all the cage is for. So any new ladder, I wouldn't recommend it. Obviously, put in a ladder climbing system, and you can put in a cage if you want, but I wouldn't put any cages on any ladder. So, all right. So, trying to get done here. I apologize. A little delay. So, cleaning, very basic. If you're going to write with a Sharpie, you got to do it with a Sharpie. It's the only thing we've approved to be written on your harnesses. If you're going to write on your harnesses, you have to put that you use Sharpie in your fall protection plan. So be very clear on that. Just soap and water. Make sure it's clean water when you're done. Don't use over 120 degrees. Make sure it dries. If you stink and you sweat like I do, you can spray Febreze. It's the only thing we've approved. You can spray Febreze on your harness. All right? And we do have specific COVID instructions, so if you want specific cleaning instructions for COVID, we do have. The last thing I'm going to talk about, what do we do once we are in a fall? How do we get down? So we have different systems depending on what you're doing. We have a safe escape system is what you see on the left, and then we have what a quick pick system. There are 2 different systems. The problem is when somebody falls. Does anybody know, if I fell right now, how many minutes you have to get me down? Jason says 5. Anybody else want to guess? It's 15 minutes. So OSHA says if I fall right now, you have to have me down in 15 minutes. If you can't, and 911 can't be your rescue plan. It can be a part of your rescue plan, but if I call, Peoria Fire Department, I assume is what's going to respond where we're at here, okay? I can tell you right now, if I fall right now, by the time if Jason and I were working together, by the time Jason calls 911 to get here, they're not going to be here and have me down in 15 minutes. Yes,
So
sir?
the reason why I said 5 is because it's a known fact that suspension trauma can start within 5 minutes.
Yep. So that's why Jason said. OSHA says 15 minutes. The problem is what Jason's talking about, those straps are cutting into your legs really quick. So anybody fell asleep on your arm? Those prickly feeling in about 30 seconds, your legs are going to start feeling. After 5 minutes, you're probably not going to feel your legs anymore. After 15 minutes, you got serious, and I cannot stress this enough, you have serious issues if somebody's been hanging for 15 minutes. Because all that blood is pooling in your legs, it's not pumping back to your heart, so you got problems there. All that blood needs to be reoxidized, you start getting septic, you go into shock, there's a lot of problems. So, say Jason finally gets me down at 12 minutes. Once he actually gets me down, however he does it with our different equipment here, and I'm not really going to go into too much details. We have videos if you want to know how to get somebody down, depending on your application. Don't allow me to lay down, because all that blood's pooling in my leg. We want that blood to slowly go back to your heart. So what I would recommend, find a chair. If you don't have a chair, you might have to get behind the person and kneel like this and put their back, because they're not going to be able to feel their legs. When you lowered them down, they're going to be like a dummy when they come down, because they're not going to be able to feel their legs, especially if it's been 12 minutes. So you got to get behind them, keep them upright. If there's somebody else there and emergency services aren't there yet, you need to put those legs up in his chest. So he's going to be, you're going to be sitting there kind of like this on the ground. So your legs up in your chest, your butt on the ground, your back up. And we want that blood to slowly go back to your heart. So don't allow people to lay down after a fall. We want to keep them upright, keep them talking. We want that blood. They're going to need to go to the hospital because, of course, that blood hadn't been 12 minutes. Doesn't sound like a lot, but it doesn't have any oxygen. There can be a lot of issues post-fall. So 15 minutes. If you don't have a rescue plan right now, you need to develop a rescue plan. And there are a lot of third-party services. I can kind of help you, but there are third-party services that can help you design a rescue plan.
So one of the things that we should probably touch on is sanitary districts have remote pump stations, correct? And a lot of times it's hard for a emergency response team to find those stations. What we've done here is we've actually put signs at the entrances, so like address identifier signs. So that's something you guys might want to think about.
The other thing would be, everybody has a phone, and you guys have remote pump stations like that. If you're the rescuer, drop a pin exactly where you are on Google. You literally just open up Google Maps, hold it, it drops a pin, and you could send it to their first responder. Hey, give me your cell phone or somebody's cell phone so I can show you exactly where you are. To his point, it's hard enough for first responders to find a house in a neighborhood. Think about you guys being lone workers in a manhole, and say you guys are down underneath the street. How are you going to describe where you are? I'm 100 feet from First and Adams, but I'm east. No, I am west. I don't remember where I am. That's the problem. So having that rescue plan and practicing that rescue plan, I would say on a quarterly basis, or at least, going through it, hey, this is what you're at. Because if it's me that's fallen, I want whoever I'm with to know exactly what to do in the event of emergency. And it's very, very easy to get flustered and not know where you are, and you forget where you are, and so you got to keep your wits about it, and that's why we practice. That's why police officers do training all the time, because they want it to make it just come to them instead of having to think about it. So the last thing I'm going to talk about is these straps. They come on a harness like this. They just attach like that. You see them there on this is what the harness is. These can be put on any harness. And what they are suspension straps. You put them on the harnesses, you cross them, and now you can stand up, sit down, and it takes all that weight off your thighs. So yes, you still have to have somebody down within 15 minutes, but now you have the straps to stop that, allowing that blood to circulate while you're hanging. So does that make sense to everybody? Very inexpensive. $10 you can get a couple straps. So, all right. So essentially, have a program in place. Again, if you don't have a program, start working on one. Train workers, all your workers, anybody working at heights or potentially working at heights, got to be trained. Can't just be 15 minutes. And then, of course, use common sense. Complacency kills. I can't tell you how many times in wastewater treatment facilities where I've seen serious injuries and fatalities. Just because, oh, we've always done it this way. I mean, I hear that all the time. And that's when you have those serious injuries. So we're going to take a quick bio break. We'll be back at about 10:34. So we'll put on mute, and once you see me standing back here, we'll start again. So unless there's any questions, no questions? All right, cool.